Hey everyone, Jamie here, popping in ahead of the episode with a couple of reminders. This is the fourth episode in the SfN Shorts series, which is a series of brief interviews that I conducted with early career researchers at the Society for Neuroscience conference last year in November. If you have not listened to the first 3 SfN Shorts episodes and would like to do so, you can find those at the In Plain English website, inplainenglishpod.org, or wherever you are listening to this podcast right now. I also encourage you to listen to this month's full-length episode, which was an interview with William Nyam, who is a host of the Reproducibility podcast. We had a wonderful discussion about rigor and reproducibility in science, and really left me with a lot of hope and excitement for the future of science. I'm also going to be a guest on the Reproducibility podcast in the next couple of months, so be on the lookout for that. So without further ado, let's get into the 4th episode of SfN Shorts. So first, can you just introduce yourself?
Absolutely. Hi, my name is Yasmine Bassil. I'm a 4th-year neuroscience PhD candidate at Emory University under the direction of Dr. Michael Boric under the Neuroplasticity Research Lab. And today I'm talking a little bit about reference frame utilization as a marker of aging-related deficits in spatial navigation.
Very cool.
Yeah. So I can talk a little bit about my poster if you're interested, and feel free to interrupt at any time with any questions. So largely we study spatial navigation because it's an early predictor of aging-related cognitive decline and the onset and progression of neurodegenerative pathologies. And so specifically what we're interested in within navigation is the idea of reference frame utilization and how older and younger adults utilize reference frames differently while navigating through a space. And so it's been shown, are you familiar with egocentric, allocentric navigation?
Can you just go over it quickly?
For sure, absolutely. Yes, so when we look at reference frame utilization in aging, we see that older adults and younger adults encode and retrieve spatial information a little bit differently. And so in the literature, it's described as if you're navigating a space and you're receiving first-person visual information through optic flow, and you're encoding objects in your environment to yourself and your own body position and orientation. This is often referred to as an egocentric reference frame. However, if you're looking at landmarks and referencing landmarks and relating them according to each other in a more third-person, landmark-oriented external way, this is referred to as an allocentric representation. And so we see that in younger adults often are able to utilize, encode, and transform between egocentric and allocentric representations easily, but older adults have a bias towards egocentric representations and often have a deficit in utilizing and retrieving allocentric representations. And so we're really interested in the behavioral and neural correlates of this reference frame utilization and aging effects on it. And so essentially here what we've done is we're interested in studying specifically immersive virtual reality city-like navigation. And so we've recruited both younger and older adults to perform a city-like navigation maze in VR. So this is using a head-mounted VR headset with controllers. And you can see in the video how they could teleport around in the maze. So it's essentially just the VR headset and then a click and release mechanism where you just click and release and it teleports you in the direction you're pointing to in the maze. And so essentially they're placed in the center point of this maze and asked to navigate to 8 unique target buildings. And so these 8 unique target buildings, they do them in the same order every time, they navigate to target building number 1 and then they're brought back to the start. And it continues where they travel to target building number 2, they're brought back to the start. They do this for 8 target buildings and they repeat this whole thing 3 times. After repeating the whole Nav City maze 3 times, they are taken out of VR and they're given a blank sheet or a sheet of paper that is a bird's eye view, an aerial representation of the maze, and they're asked to locate the position of the target buildings and the most representative path that they took to that target building as a measure of the retrieval and recall of allocentric representations. So here in the results, largely what we see. So I'll go through them quickly and then you feel free to ask questions. So in number 1, we wanted to see just in younger adults, do we see training effects on this task? Or does everyone just complete it very well the first time? Or does no one ever complete it well at all? So what we see is we do see training effects, and so we actually see training effects between block 1 and block 2 for all of the outcome measures we look at, and block 1 and block 3, but not between block 2 and block 3 for most of them. We do see them on a few. Which essentially this indicates is that younger adults are able to effectively train on this task just within the first repetition. And there are not that many differences between block 2 and block 3. But this essentially validates that there is individual variability in how people perform on this task, and people do train on this task effectively. Number 2 is where I'm really excited about the results, where it's showing the difference between how younger adults perform and older adults. And so actually what we see, so this is the same data just overlaid here, and this is just younger and just older. What we see is that even though there's individual variation, when compared to older adults, younger adults are pretty, similar in their performance, but there's a lot more spread and variation in older adults. And specifically when we compare the means of the groups to each other, one interesting thing that I like to point out is even though there's variation in how people perform on this task, the rates of learning or the rates of training are similar across groups. So if you're looking at the slope, the rates are similar, indicating that everyone trains on this task, even though people start out or end up at different places. Another interesting thing that I like to point out visually is this red line is the older adults. The older adults end up on block 3 around where the younger adults start off, which means that older adults can achieve what younger adult performance looks like. It's not like older adults can never achieve that level of performance. They can with training. And lastly, if you look at the scores of this assessment, which we call NARA, we do see significant aging effects between younger and older adults on this cognitive map assessment or this allocentric representation assessment. And then here what we're doing is we're correlating the NARA score back to some of the outcome measures from the NAV City. And we see strong correlations, which basically just means if they perform well in NAV City, they are able to recall allocentric representations well, which is a validation measure for us that this is able to capture what we want it to capture. Future directions are where I'm most excited about, so hit me up at SfN next year. And basically what we'll be looking at is the neural correlates of aging-related deficits in reference frame utilization and stimulating an area that's directly connected and involved in navigation with the retrosplenial cortex. The retrosplenial cortex has been hypothesized to really be involved in the coordination of these different reference frames, the coordination, transformation between, and incorporating both of them into like a higher dimensional representation, spatial representation. And so we'll be stimulating the stereoparietal cortex and measuring TMS evoked responses in the retrosplenial cortex.
That was really cool. I'm noticing here with the older adults that obviously there's variability in the younger adults, but with the older adults, like you said, there's much more spread. And specifically, I'm looking at this group that's like performing way worse.
Right.
So do you think that this tool could be used to maybe try to identify older adults who are potentially going to have like cognitive decline or more serious issues, and then like identify and treat that earlier?
Yes, absolutely. First of all, that you're the fourth person who said this today, which is amazing because I love this conversation. The next step analysis, if you see here how most people are around below the 100 point, one thing I'm really interested in is just if you just cut off at 100 and just took everyone above, what's special about those people? Why are they performing poorer? And yes, is it an indication of their cognitive status or even future cognitive status? So if I had endless time in the world, I would do a longitudinal study to test that, but that is a super great question. And I think literally just next steps would be to understand why these people score the way they do.
This is very cool and also giving me anxiety because I know I would do so badly.
Stop, we have it in the lab and every day I'm like, should I just like...
I'm like, I want to get in an fMRI and get somebody to like record my brain and be like, all right, you just don't have one of those, and so that's why you can't get anywhere.
Right, no, literally.
Thank you so much. This was really cool.
Yeah. Thank you. I appreciate it.
Can you just start out by introducing yourself?
Yeah, so my name is Noor Tasnim. I am a third-year PhD student in the Department of Translational Biology, Medicine, and Health at Virginia Tech.
Very cool. Yeah, so can you tell me a bit about your research?
Yeah, of course. So I'm a member of the Embodied Brain Lab at Virginia Tech, and we actually conducted this research in partnership with STEP Virginia. And STEP Virginia is an organization based in Fredericksburg, Virginia, and they run these musical theater experiences for individuals with different disabilities around the Fredericksburg township area. So they were very much interested that, after having an organization be run for a few years and through these musical theater experiences, they found subjectively at least that improved sense of like mental health and improved sense of like community within these individuals who've been participating within these musical theater experiences.
Oh, cool.
And so they were very much interested in seeing if there was a rigorous qualitative and quantitative way to actually see these effects within their participants as well. And so that's where our lab got involved. And so we are big proponents of community-based participatory research, also known as CBPR. And so we actually came to Fredericksburg and actually consulted with not only the parents, but the actual participants themselves to see what sorts of questions that they would like answered, as well as what sort of EEG or neural data that they would like collected in relationship to their musical theater experiences as well. And so the study was designed with what questions that they had initially in mind. And so we eventually enrolled 16 individuals within our study. They were between the ages of 9 to 30, with an average age of about 18 and a half.
Okay.
And so 12 of those individuals had autism spectrum disorder, 3 of those individuals had intellectual disability, and 1 individual had a chromosomal abnormality.
Okay.
And so when they did engage in this sort of musical theater practice, it was a 4-month rehearsal process where they rehearsed 2 hours a week with 1 week of rehearsal per month.
Okay.
And at the end of their 4-month rehearsal program, it was a final showing of Charlie Brown, the musical.
Oh, that's very cool. Actually, my high school did that way back.
Oh, awesome. Yeah. It was a lovely musical. And they performed it so well, and they're so talented. And so we were able to collect some of their survey, like mental health data through validated questionnaires that were administered before the 4-month training program and immediately after the 4-month training program. And so what we eventually saw, the big picture here, is that we saw an overall decrease in anxiety.
Okay.
And this decrease in anxiety was driven by a significant decrease in social phobia and separation anxiety. So that's implying that with this sort of musical theater engagement, because of the strong community that's been established through this program, we were hypothesizing that this sense of community decreased that sort of social phobia and separation anxiety that we're seeing, that eventually influenced this decrease in total internalizing and anxiety. But what we were also interested in looking at was looking at the brain activity of these individuals while they were engaging in these musical theater practices as well. And so what we ended up doing is that each individual had a 32-channel wet electrode EEG cap on, and it was fully mobile. And so through the sort of like mobile EEG paradigm, we had them go through these like interactive movement, musical experiences. One was like just going through a pre-baseline session where they just kind of sat down, looked forward. And then afterwards, they went through like a whole breathing practice, a guided breathing practice. So 3 minutes of like deep breaths going in and out. And then afterwards, they engaged in a movement mirroring experience where they looked at each other and mimicked each other's movements. And then lastly, they engaged in an actual musical experience from Your Good Man, Charlie Brown. And so what we eventually saw is like when we were looking at these power spectral density plots is that there was a general difference in power in between most of the activities, but we saw a higher amount of power in delta, theta, alpha, and beta for movement mirroring, which is in light blue, and musical experience, which is in green. So when I talk about powers and frequencies, when you're looking at EEG data and looking at the different like frequency components and oscillations, right? A lot of that data is coming into like different oscillations. And so the oscillation can vary in speed. So are they fast oscillations? Are they slow oscillations? And that's how we can piece them apart as to like delta, theta, alpha, and beta, as to how many oscillations per second are we seeing. So that's how the Hertz value comes in.
Okay, so the speed is like the name, the alpha or theta, okay.
And what is quote unquote power is the amplitude that we're seeing in the oscillatory activity. Yeah, so delta and theta are typically associated with like a little bit more like restful, like stress-free states, where alpha and beta, they're more engaged with like higher cognitive effort, concentration, focus, attention, and memory.
Okay.
So what we were very much interested in seeing was, all right, once you engage in this pre-baseline session and engage in these musical experiences, is there a difference post-baseline as well? So again, after you do all these musical experiences and then sit down again, is your brain state fundamentally different?
Okay.
So when it came to delta and theta, there were no significant differences, and they're indicated by the black bar here, which there is none. But when we look at alpha and beta, there was some sort of difference within 8 to 9 hertz in pre to post baseline, as well as throughout beta. Post baseline is in blue, where you're seeing higher power.
Okay.
Yeah, and green is pre baseline, where you're seeing that lower power. So again, we're seeing this sort of like different power, right? When it comes to these frequency bands associated with like more like cognitive effort, working attention, and memory. So what we were interested in seeing is like, what does that information flow look like in particular, right? And so we were looking at intra-brain synchrony, which is that upper analysis to the right. So what we ended up doing is compiling every single connection point within all the electrodes that we have. So we created a matrix with like a 32 electrodes going down one way, 32 electrodes going down another way. And then we just assessed imaginary coherence between every single electrode pair. And then we averaged them across participants. And then once we averaged them, we displayed a z-score value of, so like using the mean and standard deviation. And so all of those red lines that you see in the upper right corner for intra-brain synchrony, those are all values of connection that are at least 2 standard deviations above the mean. And so what we end up seeing is when you compare alpha, especially from pre-baseline to post-baseline, we're seeing this sort of like increased connectivity, right? But what we're also very much fascinated by is seeing like this global connectivity within post-baseline. What I found fascinating is that with alpha and theta and delta and beta, they're all pretty much localized in different regions, right? So I felt like that was implying that we're seeing this increased sense of information flow immediately after we're engaging these musical experiences, and especially in like alpha as well. And then lastly, we're very much interested in like the social brain as well, particularly within the frontal temporal regions of your brain. And so what we wanted to look at was inter-brain synchrony. So we used this concept called hyperscanning, which is where we were scanning multiple people's brains at the same time simultaneously.
Okay.
Yeah, and so we had dyads and triads interact with each other, and we took all like dual pairs, averaged them together, and again, did the whole z-scoring method, where the darker the lines are, the further they are away from the mean. The big thing that we noticed here is when you're looking at beta, which is again typically associated with like working memory, we're seeing this sort of like ipsilateral connection across individual pairs. So these head maps, it's as if two people are looking at each other topographically. You see their little noses right here, you see their ears right here. So again, so we're seeing this sort of like deep red positive connectivity to the left here, more in movement mirroring as well. And overall, when we look at alpha and musical experience, we're also seeing this sense of increased connectivity. So again, so we're seeing these trends in like alpha and beta, again, that are associated with like high concentration, focus, and cognitive engagement, implying that when these individuals are getting engaged in these musical theater experiences, it does have some sort of effect on like executive function as well as a positive effect on mental health. So it's implying that like, hey, like, like we are seeing like positive social effects, but also adding to the fact that, like individuals with autism spectrum disorder, intellectual disabilities can be engaged in these musical theater experiences, but also feel the same effects as like everyone else does as well.
So how long after the musical theater experience was this mental health screening done for the post?
It was immediately done like after the final performance.
Okay. So are you all looking into doing like a follow-up to see if those changes in the social anxiety and the separation anxiety are durable and last for a longer time?
Yeah, so our eventual goal is to like make this into a longitudinal study, mainly because a lot of these participants continue coming back to the organization in Fredericksburg. So we have the potential now that we have like IRB approval, we have preliminary data to continue running these analyses over the years, especially when they're engaging in different musicals as well.
Yeah, so you can see how like more long-term practice and exposure affects their mental health.
Yeah, of course. Yeah.
So thank you so much for agreeing to be recorded for this.
Yeah, of course. Yeah.
Can you just introduce yourself, please?
I'm Chantelle from the Centre for Neuroendocrinology in Dunedin, Otago.
Excellent. And then can you tell me a bit about your research?
So I'm looking at how maternal food intake is elevated in pregnancy and lactation. And first of all, I've been looking at a hormone called ghrelin, which stimulates appetite, and how that may or may not stimulate appetite in pregnancy and lactation.
Okay, so ghrelin in like a normal situation makes you hungrier.
Yes. Ghrelin is secreted from the stomach when you're hungry, and it makes you seek out food and eat. Okay,
got you. All right, and so then can you tell me then a little bit about how that changes during pregnancy?
So we injected ghrelin into pregnant mice, and essentially what we first saw is that ghrelin does not stimulate appetite or food intake in pregnancy. So if you inject this into a virgin mice, they'll seek out food and they'll eat more than a saline control. If you inject them into a pregnant mice, they do not eat more than in the saline control.
Okay, and is that kind of from the start of pregnancy, or does it like switch at some point?
So we looked at 2 time points. We looked at the 2nd week of pregnancy, which is early on, as well as the last week of pregnancy, which is late on, and found that at neither of these time points there are a difference in food intake with ghrelin or saline treated. So we're thinking this starts pretty early on.
Okay, got you.
And so then we looked at how the insensitivity to the food intake response of ghrelin might be mediated. So ghrelin activates a neuron called AGRP, which stimulates food intake. And since food intake is not being stimulated, we wanted to look at these AGRP neurons and how they are acting within pregnancy. What we found was using a neuronal marker for activation, ghrelin is increasing the activation of AGRP neurons in pregnancy. So the same as in the virgin state and the same as in the lactation state, these neurons are activated in pregnancy and therefore should be leading to a food intake response, but is not. We then further looked at the AGRP neuron activity in pregnancy, and we found that these neurons are still responding to ghrelin using a fibre photometry measurement which records temporal response to the hormone ghrelin. So we can see a rapid increase in pregnancy day 8 and a slightly slower, more blunted increase in pregnancy day 15, but this is not different over the 10 minutes of ghrelin, showing that when you inject ghrelin, AGRP neurons are still responding in the same way as in the virgin state, even though we aren't seeing a food intake response. So our conclusion from that is that the food intake insensitivity to ghrelin must be mediated sort of downstream further within the brain from the AGRP neurons. We then, continuing to look into how elevated maternal food intake is occurring, looked at a response to chow, which is the rodent diet, and we found that during pregnancy, once you eat food, the AGRP neurons generally shut off in the virgin state, and in pregnancy, in that last week of pregnancy, these AGRP neurons are not shutting off to the same extent, which means that mice might be devaluing their food and looking to eat more and gain more caloric value from the food that's in front of them, so larger meal sizes or longer meal duration.
Right, I was going to say, so they'll maybe keep eating instead of like having some food and then stopping.
Yeah, so generally how that AGRP response works is a sensory response first. The mice will see the food and the neurons will shut off once they've deemed what that food is and how calorically valued that food is. And in pregnancy, we're not really seeing that initial sensory response. So I think they're looking at the food and they're going, I need that. They're eating it because they're not eating it differently to the virgin mice, but their neurons are making sure that they don't turn off so that they can eat more within that meal and then turning off once they get enough calories.
Okay, so it's more like they're sort of eating like regardless of this AGRP neuron level instead of like having the level decrease and then.
Yeah. So it kind of looks like these AGRP neurons are just not shutting food consumption off. Okay. They're kind of trying to keep it a little bit higher so that you get more.
Yeah, because they need to eat more food.
Yeah. And then again, in lactation, we looked at the ghrelin response and we see that it's no different to the virgin animals, which is expected. So they increase their food intake. But again, with this response to chow, these neurons are not shutting off at all. So in lactation, mice eat 3 times the amount of food that they do in virgin, so up to 15 grams in a day. And I think with AGRP neurons not shutting off, it's really saying, now that you're at food, eat as much food as you can get.
Yeah, for sure. Yeah, that's super interesting. So how can this kind of inform like some of the things that we see in pregnancy with people? Does this work connect at all with like diabetes during pregnancy or like some of those other things that you might see?
So in terms of what I have kind of concluded with a lot of the research I did in my PhD was that we have now seen an insensitivity to satiety hormones, so insulin, leptin, CCK, which all tell you that you're full. You're not responding to them in pregnancy. You're also not responding to ghrelin, which is telling you you're hungry in pregnancy. So either there is some sort of like a prolactin or placental lactogen or progesterone hormone from the placenta, which is taking over and trying to control food intake, or you're not really getting a control of food intake during pregnancy. So when society kind of has the saying, you can eat for two, and people are pregnant and they're eating their cravings and they're eating as much as they like and they're snacking, they might not be feeling that satiety or that hunger really, and just eating what they think is right, and therefore gaining too much weight, or going into more sugary foods with cravings and not quite getting the right nutrition, because within the brain we're seeing something is completely turning off normal regulation of food intake, and so that's kind of being taken over in a different path.
Right, the kind of regulation that you usually have isn't there, which kind of, I feel like, tracks with how people experience pregnancy in general. Like you were saying, the cravings and just eating more and different kinds of food than you normally would, like when you're not pregnant, like that kind of would track with some of these feeding regulatory circuits being offline a little bit.
Yeah, 100%. So it could be completely that you're not really getting any control of food intake, and so your sensory, the whole like smells, the cravings, the what you're seeing is taking over, and then when society says eat for two, you're just eating what you like in pregnancy, which is not necessarily always the best thing. But if your body's not telling you any different.
Right, then you're like, yeah, we might as well, right? Yeah. And so then does this response of the AGRP neurons to chow go back to normal when they stop, like when the pups are weaned?
Yeah, so once the pups are weaned, that response does go back to normal. We also see that the response is normal with with peanut butter, so something that's more got a higher caloric value, more like a treat. That response is still there. It's just with their everyday food that it's not.
Okay, that could also potentially. Do you know if like the shutting off this AGRP neuron signaling, is that like rewarding in itself? Like, have people done tests to see if you can like optogenetically shut off these neurons, and then do mice prefer that? Yeah, so mice do prefer to have the AGRP neurons shut off. Having them fire is a negative valence signal, so it's a discomfort that they don't want. So yes, if they had the choice to shut them off, they would shut them off. But exactly how that works with straight food is not 100% known. With projections from other places, if you're eating, you've got projections from sort of leptin-sensitive neurons that shut these off, saying we've got enough food, we've got enough storage of food, so we can turn you off. And so another sort of pathway that might be regulating why these neurons aren't shutting off is you've got a resistance to leptin in pregnancy. So if you don't have leptin telling these neurons to shut off, they're not shutting off. Yeah. And then in lactation, because it's such a big energy deficit, you're eating so much because you're expending so much energy, you've actually got really low levels of leptin. So again, if you don't have leptin levels telling you that you've got the sort of storage of nutrients in adipose tissue, then you're not shutting off those AGRP neurons through that pathway. Yeah. Whereas something like peanut butter, why you might be getting that decrease is because it's a rewarding food, so it's not homeostatic control, it's hedonic control, which is a whole reward pathway which is different to the AGRP neurons, and it's kind of going and saying, yum, getting the treat, eating the treat, responding to this treat, getting reward from it and kind of moving on, right, yeah, rather than looking at the treat and going, oh, I'm going to eat my whole day's worth of calories in peanut butter. I would love to eat my whole day's worth of calories in peanut butter. I don't know about you.
Same, absolutely, yeah.
Yeah, no, I was just wondering if like part of the differences that you see in feeding during pregnancy are because that like rewarding food is even more rewarding because you're not getting that same like reward just from eating normal food. You're like, oh, I need to get this from eating like this super rewarding food.
It could be, 100% could be. It would definitely be in a different pathway to what we're looking at. But yeah, it's something that can be looked at, and I don't think has been looked at enough in pregnancy.
Yeah, well, thank you. This is really, really cool.
Hey, no worries.
Thanks again for tuning in to this episode of SfN Shorts, featuring the work of Yasmine Bassil, Noor Tasnim, and Chantelle Murrell. You can follow along with their posters at inplainenglishpod.org. And again, we will be back next week with another episode of SfN Shorts, so do stay tuned for that. Our music is by Sam Brunwasser. You can find more of his work at soundcloud.com/visualsnowbeats. As always, you can download the paper and read the transcriptions at inplainenglishpod.org. And make sure to follow us on Twitter, Facebook, and Instagram at Plain English Sci. That's PLAINENGLISHSCI. Thanks again for listening, and we'll see you next time for another episode of In Plain English.